Hello, and welcome to our webinar on enabling continuous testing in an agile-based DevOps environment. As some of you may know, this is the third presentation in our series of presentations on the 4 dimensions of DevOps. And this is Sridhar, and I also have Jayanti with me. I am a technical architect and technical consultant, and Jayanti is a senior test automation consultant. So before we jump into our presentation today, I'd like to give a few quick introduction on my company, on the company that I work for. I work for Aspire Systems. It is based out of India, but we have presence across the globe. So just to go through the stack here, we are a global technology services firm with core DNA of software engineering, which means that we specialize in products, development of products, and the whole life cycle of it. We've also trademarked what we call the product tiering, which specifically deals with management of product development. We are also experts in a lot of software engineering principles, digital services, testing, DevOps, and infrastructure and application support. We are certified partners for Microsoft Azure and Amazon AWS. We are a CMMI Level 3 certified and ISO 9001 and 2008 certified. We also have the ISO 27001 2015 certified. Our international headquarters is in Singapore. Our development centers are across the globe, with a bigger portion of it in India. And we also have a lot of presence in the US, UK, the Benelux region, Middle East, and Singapore as well. A few other growing areas. We've been recognized 8 consecutive times as the best place to work for by the Great Places to Work Institute. And yeah, as you can see, there are a lot of accolades that we've received, and we'd like to present our accolades right here, so you could see the list down there. Having talked about Aspire Systems, let's jump into today's topic. And today's topic, as the agenda would say, is we would first recap what a templated approach is. As the topic suggests, we are trying to come up with a templated approach for DevOps. And we covered a few concepts in the previous 2 webinars. Today is all about continuous testing, but we'd still like to do a small recap of what was discussed earlier. And we'll continue on with continuous testing and then apply the templated approach for continuous testing dimension to see how we can use the templated approach to choose continuous testing tools, processes, and things. Moving ahead. So to recap, we talked about 4 different dimensions of DevOps. Based on our experience with customers, we clearly see there are 4 different dimensions. They are segregated in a way that they can be worked on independently and, also parallelly. But although they have an interconnection, it still is a separate silo. So these 4 dimensions can be addressed in their own ways without interference from the other dimensions. And each dimension has its own characteristics. So these characteristics are determined by 5 different parameters, 5 different categories of parameters that we see. And this is purely based on our experience with all of our customers. We do projects for a lot of our customers. We've executed at least 200 DevOps projects. So to clarify, to recap, the 4 dimensions are infrastructure management and automation, release management and continuous integration, continuous testing, and the final and the core part is orchestration, monitoring, and the feedback loop. We already covered infrastructure management and automation in a previous webinar. We are skipping over to continuous testing in this webinar. So we'll try to look at how DevOps and continuous testing go hand in hand. So for each of these dimensions, the parameters are quite common. To list them, the first parameter such as distribution. So it talks about how your teams are distributed, how your product is distributed, how the application itself is distributed. So it talks about distribution in general for everything that a product needs. The second parameter is technology, the technology stack, any other technical parameters that are required, which is obvious given that it is a technical topic. The third parameter is scale and load. So depending on the scale and load of your application, the operations, the tools that you choose, everything would change. Everything needs to adapt to the scale and load of the application. And the fifth parameter is environments and security. So depending on whether your application is deployed on the cloud or in a hybrid model, or it is purely on-prem, or it is a completely internal application that is locked within a smaller group, or however it is. So environments and security play a major role. And when I say environment, it also deals with several stages of your development. You could have multiple teams working at different stages, adding on to a product and then a final release going out. So there could be possible segmentations within your development cycle, which is what is specified in the environments and security layer. And the fifth parameter is your release such. So it deals with how frequently you release a product, what is your control structure to release a product, what are your control mechanisms, processes, and all that. So these 5 parameters are the core parameters that determine everything that you need for a particular dimension. And these 5 parameters apply to all your dimensions. So to put it in short, all these parameters are your core parameters for the entire DevOps operation. Moving on, so with the templated approach, what we are trying to achieve is arrive at a table that looks something like this, which basically determines the tools, processes, and control mechanisms that are needed across each dimension chosen based on the parameters that we've determined. So the parameters are your real-time characteristics or real-time input from your actual development pipeline. And these dimensions, like I said, they are impacted by these parameters, and so the tools and everything will depend on what is the input. And this process is sort of generalized to come out with a template, and there are mathematical models behind it to come out with this table so that it's easier for you to readily take in use. So moving ahead, let me first quickly cover what continuous testing is, why are we even considering continuous testing as part of DevOps. We've seen that it is somewhat a debated topic. A lot of people don't see continuous testing as part of DevOps, but in reality, what we've seen across our customers is that everyone wants testing to be a part of their DevOps pipeline. And it is common practice that testing is your quality check-in that needs to somehow control and stop releases. So in our view, continuous testing is definitely a stage, a dimension in our DevOps pipeline. And that is why we even considered that to be a dimension, and that is why we're even talking about it. So what is continuous testing? I'm pretty sure most of you would know all of this, given that you're already here, but we'd still like to go through the basics. By definition from Wikipedia, continuous testing is a process of executing automated tests as part of software delivery pipeline to obtain immediate feedback on the business risks associated with the software release candidate. So as it clearly says, it is automated tests. It is continuous. So as someone releases code, you do a continuous, you do an automated test, make sure that it passes all your required business needs and release it. So that's the basic core definition of continuous testing. Now, why do we do it? It to provide fast and continuous feedback, fail fast to enable faster feedback loop in the sense. So as soon as someone commits, if you're able to tell him or tell the developer that it failed, it is a lot of saved time for the developer and for the entire organization. And automate testing of every commit, which is obviously what continuous testing is about, and act as a gatekeeper for the product. Like I said, they are the quality control, so they protect bad releases from going out and provide metrics on development efficiency. Now, this part is somewhat important in the sense, depending on how frequently builds fail and all that, the metrics can actually be a very, very useful input to the development team to do any further improvements. And that is why that is also a part of the goal. The challenges in implementing it is again quite common. A lot of people have gone through this, but we'll just go through the list and see if we've seen any of this. So coordination of changes and build processes with all stakeholders. Typically, if it's a very small organization where the pipeline is very streamlined, this may not be very prevalent, but in companies that have grown beyond a certain point, they have a lot of components, a lot of products, a lot of things that go out of the normal process and do things outside of norms. And that's when this coordination becomes a little difficult. People tend to look at this process, this control mechanism as a hindrance, but to be frank, these are the gatekeepers and they should never be skipped. Continuous testing should always be enabled for every single line of code. The next challenge is continuous maintenance of automation scripts and tools, which obviously is a major challenge because with every change that comes up, there is always a lot of scripts associated and those need to be updated in the right time before a developer releases should sync. It may be sometimes that a test script may be injected before the actual code changes, so which can fail the build, which is a false positive though. In which case, the coordination between a developer and a tester and between someone who writes the scripts is still important. So that coordination and that continuous maintenance of automation scripts is a challenge. The third challenge as we see it is with all the cloud environments, with all the advancements in the cloud technologies, be it VM based or container based or however it is, provisioning of dynamic testing resources on the cloud, getting data from it, all that is quite tricky, especially if testing also includes your performance testing and all that. Obviously, the amount of data that it deals with, the amount of processes, the amount of resources that it consumes is quite high, which is a primary factor, and that is also a challenge. Provisioning for them, making sure that they are running, they are given enough memory and all that, allocation of everything is important. Keeping them running and keeping them for every build is not just a difficult problem, is also an expensive problem. So based on what we've seen of continuous testing, let's look at a few trends and concepts which I think are mostly common. People who know testing really well I'm pretty sure would have read about these somewhere. But we'll just go through them to see if we can fit ourselves in somewhere. So the most popular trend right now is acceptance test-driven development, which used to be test-driven development, behavior development. It grew from several concepts, but right now I think the trend is doing acceptance test first programming. So developers, before writing any code, they have requirements in the form of acceptance tests, which I shouldn't really call it requirements, but still that's what it is to a developer. The developer doesn't have to look at the actual requirements anymore. A tester starts with basic requirements, writes the acceptance tests, and with that test, a developer starts writing code. So it just makes sure that the acceptance test passes before even it crosses development. So it is just one simplification layer, one change in process that improves quality leaps and bounds. Right. So that is an idea that a lot of people can implement. It's nice to have. We've seen it work in a few of our products or projects. And distributed testing. When I was talking about distribution as such, today's products, most of them are delivered as services or delivered as global products deployed in multiple regions and so on. They have huge loads and expectations, and to test them is a much bigger expectation, a much bigger problem. And that again brings us to provisioning resources, managing the resources, recovering from failures and all of it. So that is a trendy concept right now. People are working on such a setup, making sure that nothing fails, making sure that their given load conditions meet, making sure that the tests are running in a distributed manner, runs in different regions, and so on. Right. So that's one. Fail fast strategy. It's nothing new, but it's still a trendy concept. So people would want to know failures as soon as possible. So to enable this, there are multiple ideas that people use. One is multi-stage testing, where the whole test suite is broken into smaller pieces. So the first stage is a very basic regression test that probably makes sure that only certain core components work. And if there are failures, it fails immediately. And having it multi-staged enables the process to determine failures as soon as a stage is reached. So the stages can be designed in a way that you look at the most important stuff first and then go in that priority order, which is a nice strategy. Similarly, there are ways to execute tests parallelly, make sure that multiple, although you spend more on that kind of a test setup, it's still useful because it'll let failures known immediately. So that is one other strategy, regression strategy, which is quite, everybody does it, but there are certain things that a product as such should look at. Whenever there are upgrades, the backward compatibility of upgrades is an important problem. So people tend to rely on upgrade packages, but the backward compatibility of them is in a lot of cases ignored. At least from my experience, I've seen a lot of products that completely ignore backward compatibility. And when that happens, regression strategy mostly fails. So you cannot run the same script on the update unless, of course, you have to provide the update package as well along with your release. And typically, the updates the release cycle for updates is not along with a actual release. So it's a difficult strategy to come up with, although regression testing is something that almost everybody does, but the planning for it is not very common. But when we talk about regression strategy, it is somewhat advised to look at backward compatibility and API versioning, the compatibility matrix of your versions of services, and so on. Right. Test automation. I don't really want to go into it. It's common. Everybody knows what it is. People want test automation, and it's trending right now. API-driven testing. So instead of Selenium, things like SOAP UI and all the API-driven testing have taken over. Although Selenium is still in place, I mean, not really still in place. Selenium is still a strong player on the front-end side. More focus is placed on the APIs, given that a lot of projects are moving towards a service-based ecosystem. So maintaining APIs, ensuring their performance, ensuring downtime has become important now. So API-driven testing, it has become quite important and trending now. There are also gatekeeper strategies to say what is the definition of a failure and when should a product be released and when it shouldn't be. So there are multiple strategies, but of course the most common is zero tolerance. People simply fail for any small failure. It's the best way to do, best way to go for, because it just ensures 100% quality. But yeah, that's something that can be a strategy associated to it to say who or what protects a release from going further. And supporting product variations and combinations, like I said, if there are multiple modules and products and their combinations, managing their test suite is again a tricky problem to solve, which is addressed in a certain way. Metrics and analytics on continuous delivery, being the gatekeeper, being the quality control. I think continuous testing is the place where the metrics can be properly analyzed, can be accurate. So that is also a trending concept in testing. Moving forward, so how is CT and DevOps connected, continuous testing and DevOps connected? So these are the core points: enabling automated testing and results management, manage failures and trigger appropriate actions, provisioning of infrastructure and all the intelligence associated to it, enabling testing combinations of modules and products, and build pipelines that span across the functions of development. Going forward, so as I was saying, we will be dealing with a templated approach, and we from our earlier presentations, you would have noticed that these exercises basically cover a standard set of use cases where the template is used and where we apply our own logic and ideas to come up with a template that can be used readily. And this exercise is basically coming in from our previous webinars, but in the interest of time, we'll pick only a few of these exercises. But if you ever have time to go through our previous webinars, these are the four use cases that we commonly deal with. In-house development, where everything is in-house, nothing is outside. Hosted public-facing service, where a single application is a public-facing service, and it's quite simple. The pipeline is straightforward. A product development cycle where there are multiple chains or multiple pipelines. Say there's a development pipeline, there is customization pipeline, and so on. The fourth use case deals with a SaaS service where there are multiple services, there is coordination between services, and a lot of complications associated with it. So Jayanti, who's our testing expert, will take you through the list of tools and everything associated to the template and testing, and see how we build a template from here. Jayanti, do you want to take over?
Thanks, Sridhar. So here we see a spectrum of tools cutting across and supporting the continuous testing in a continuous delivery pipeline. So we get started with a typical functional regression test, which is more from a user interface testing. And then it also includes the next-gen platform wherein everybody is working towards the digitization initiative, which covers the mobile test automation. And the other aspects of the trending aspects, the current trend of when the GUI interface is not ready and somebody wants to see how stable will the system react or how quickly will I be able to go to the market. It is through testing these supporting peripherals, which could be either in the form of a kind of API. So there we have a set of tool stacks, and supporting these three layers, which is the GUI, API, mobile development, we have the continuous integration pipeline facilitated by a few bunch of tools. And in addition to the normal functional checks, we also go validate the non-functional requirements as such, which is more from a performance, security or vulnerability point of view, and also the usability aspects. So here you see from the functional and regression point of view, Selenium WebDriver, which is kind of a market leader currently, which is an open source and provides all programming capabilities to be deployed right away for any web app. And then commercial set of tools here, CleanST, Test Complete, Silk Test, Coded UI and stuff. And coming to mobile test automation, here again a stack of tools like APM, Calabash, Muex for handheld devices, and Test Complete, again a different flavor of Test Complete, which supports completely the mobile test automation, Perfecto, Xamarin, Device Anywhere, and Monkey Talk. So these are all the notable tools that is currently used in the market to just aid continuous testing process as such. While we see other aspects like even the next type of the flip side of functional testing, that is the non-functional testing, or is also gaining key importance from an end user perspective. So coming to the usability aspects like a typical layout distribution, the look and feel of the application, font distribution, alignments, and how localization is being implemented in a particular application or a product. So these are all done with the next set of tool stack, as you see here, like Squish, Click Heat, User Fly, User View, and Click Tail. And coming to the next layer, wherein we see like the other non-functional aspects of security, which is done predominantly through ZAP being an open source. So it provides two scanning mechanisms called active and spider scanning, through which this tool automatically does a kind of fuzzing logic, tries to attack the vulnerable parts of the application through cross-site scripting or a kind of exposing the sensitive details of implementation. So it just does a fuzzing on top of the application and tries to figure out what are all the vulnerabilities present in the application. And next comes the set of licensed tools like Veracode, Fortify, and QA Inspect. So these are all some of the tools which can be right away integrated as part of the continuous testing process, so that we give a kind of 360-degree overview covering the functional, non-functional, usability, and over and above all the different aspects of testing as such. So having built a kind of complete continuous testing tool solution, so we also see that it can be pipelined with the kind of delivery model that is present using Jenkins, VSTS, or TFS. So the next thing we see here is a kind of tool solution kit, or the Saline features that continuous testing would look for in the slide which was discussed before, which was talking about a kind of variety of tools present in the market and being used across projects and across domains, across businesses. So how do we just zero down and say which tool can be a best fit here? Of course, every tool has to have this kind of features like page objects, wherein we just generalize the application screens into kind of modular pages, and then we say these are all the kind of attributes present in a screen, and this is what the test objects which are actually intended to be carried out as part of our testing. And then how do we locate them? Then we get into a typical product or a kind of application which is undergoing a frequent release management cycle. Everybody would be looking at a kind of continuous testing as a feedback as a gateway which provides fast feedback, and as well as a kind of automated tool which just aids in a kind of code promotion. And how quickly, the other thing which even Sridhar was pointing out is another aspect is how quickly am I able to go and tune these automated scripts which are existing in place to support the continuous testing of this application. So it is through this modularized page object model, the screens are converted or translated into kind of modular pages which with the tool compatible layer of definitions. So, and there is a change or any impact being imposed in the application, then it would be a kind of right away approach for the automation tester to go correct that particular piece of code and bring in that particular integrity within the automation script. And the other features that we predominantly look for as part of continuous testing is to what extent am I able to test with varied data? Am I able to test with the positive data, negative data, or something like a kind of business rule wherein I'm able to test on a range, between a range, above a range, below a range, and what is the kind of error which the system throws when there are invalid inputs, and how intuitively the error messages are helping the end users completely from a business point of view. And if at all there is a validation which is to be performed through a typical ODBC connectivity by connecting to the source applications database like a typical Oracle or a DB2 or even an MS Access, a MySQL or anything, so that particular provision will also have to be absorbed as part of a continuous testing activity. And having talked about the main layer of the user interface and the data which is going to flow in, and the next part is where we bring in all the configurations and how configurable is this approach. Today I'm just going to test one country, one particular piece of code which is implemented for one single customer. Tomorrow this application is going to take a big way and it is going to get distributed for a bunch of other customers. How quickly I'm just able to go configure the configuration list and just re-execute, reuse the complete aspects of the test automation and derive meaningful reports out of it, which will just take me through from an UAT tester point of view, from an user acceptance, how quickly the reports are available to me, and to what degree of precision and accuracy, which will right away drill down and say that this is the step you have executed, this is where your application has traversed through, this is the test data you have tested, and this is the end state of the application or the end state of the API results which have been fetched. So these are all the key typical parameters which have to be looked up as part of continuous testing. So the right side of the block, which actually talks about the best practices, which is also part of the continuous testing we implement. So one is the localization, wherein when the same application which is being rendered across language platforms, how quickly we can reuse the same automation script. And utilities, like when a test case fails in between an execution, how quickly the application is able to recover from that particular failure and get on to the next test case execution. Or if at all it's going to be a fatal error, how quickly the application is going to get restarted and then come back to the focus wherein it can get re-executed in the CI pipeline. So these are all some of the common error handling or the error logging mechanisms that forms a best practice of continuous testing. So having built all this, how quickly I'm able to go connect with the CI pipeline and be a unique lever for a particular enterprise or any application or a product to get transformed completely into a DevOps model. So this is the best practice that we always have to look for while implementing a continuous testing in a particular landscape. And the last thing block which talks about the test script grouping is more from a logical separation of test scripts. So when we say it's a huge application and it has got to cover 100 critical business scenarios, and then further when there is a time crunch that I'm not able to certify all the 50 business flows, or when there is a right away requirement known to me from the design change or anything, like it is only a portion of the application which is going to be impacted, and it is good enough to run a few scripts from the particular suite of 1,500, 2,000 or whatsoever number of scripts. So there this particular test group grouping always helps us. It is like based on a particular module, functional module, or a test case grouping or anything, we will be able to bifurcate and then we will be able to execute the particular scripts. So here we go with the first use case, which is a hosted public facing service, and how we the templated approach gave a big way in just deciding the desirable toolkit, which has got all the features that we have discussed in the previous slide and take it on to a kind of solution for implementation right away in the production while we were doing a kind of continuous implementing a continuous testing for the continuous delivery model. So here the landscape is something like this, wherein it was to play with 5 different geographies, and then the end users were pretty much distributed across geographies, and then the end users base was pretty high, like it was around 10,000 concurrent users. And from the testing point of view, the volume which was to be tested, it was around 3,500 to 4,000 cases, and it had a kind of definite suite-based allocation, like module-based test suites, smoke-based test suites, regression-based test suites, integration-based test suites, and also all these kind of test suites, that is all the 3,500 test cases which were just formed, which were just grouped under these 3 buckets, have to be ideally executed in multiple varied environments like cross browsers of around 7 browsers in combination, and cross devices, and then further integration with the cloud platform like Sauce Labs. So this is the kind of distribution, scale and load that the particular application had to be tested from a typical continuous delivery point of view. So the challenge here was, as the number is pretty huge, and also it's like not only one web browser wherein we can test right away and certify that the code can be promoted to production. So it's like varied device fragmentation, cross browsers, and different flavors like IE10, Edge, Safari, Opera, Firefox, iPad devices, Android tablets, and everything. And on top of everything, since it had a kind of varied geographical distribution and a kind of varied distribution in the production, varied kind of users from different geographies hitting as such, the application had the service had a kind of clear controlled release management cycle, wherein it has to pass through definite quality check gateways, and the amount of regression which has to go in was pretty huge. So the one-time effort for regression was costing around 150 to 160 hours of regression, and it is impractical to just invest manually like 150 to 160 hours of regression to completely screen the application, scan the application for the backward compatibility, and then further say a kind of go to the next level of code promotion. So here is where we just did this kind of a templated approach, and then narrowed down with a kind of set of 2 tools, and picked up with, and then finally went ahead with one particular solution stack. So which is here the solution stack comprises of Selenium WebDriver, Selenium Grid for multi-threaded parallel execution, Jenkins for continuous integration, and Sauce Lab for cloud execution. So the Sauce Lab on-demand plugin is something which enables the interaction between the Jenkins and Sauce Labs. The process of bringing in or inducing the continuous testing as part of the CD pipeline is the automated test cases from the Bitbucket repository. They were just triggered by using the Jenkins during each check-in, check-out process, ideally whenever there is a code check-in happening in a particular environment. And from this, the call gets routed further to the cloud environment, which is next the Sauce Labs. And through the Sauce Labs interface plugin, the continuous testing is facilitated, and parallel threads of automated scripts are being executed. So the key control mechanism we had here was the set of, since it was a huge count for regression, 3,500 test cases were bucketed into 3 logical layers, which is smoke, regression, and then integration. So the success factor of one suite actually gives rise to the execution of the next suite. Say, for example, there is an application error or something else has gone wrong in stage 1, then it would be detected in the smoke stage itself, and an email would be triggered to all the corresponding stakeholders, giving them a heads up like this particular breakage is there in today's deployment and something needs an action ASAP. And this is a control kind of quality gate check which was actually involved in this particular templated based elimination process, and introducing a continuous testing to support it. And as part of continuous testing, the UAT users were supplied with all kind of screenshots and evidences which were just captured by the tool on the fly during the execution. So here in the next slide, I'm just going to explain the kind of weighted average and method that we used to rate the two different solution stacks which we had examined for this particular solution. And then we went ahead and did a scoring, like which one would be the best fit for this particular continuous testing needs, and then narrow down on picked up the Selenium tool stack as a final solution for this. So taking into account whatever we discussed as part of the Selenium features or the kind of tool solution kit which has to exist for a continuous testing process, which is externalizing the data, configuration, everything, and access and mainly from the costing point of view, whether it's an open source or kind of license, and further integration with cloud, detailed reporting, parallel threads, and giving flexibility to a automation tester to go ahead and program it from all dimensions, making it possible to test all business scenarios, not only positive, negative, but also the exception scenarios. So here, then Selenium was the best fit as we see from the scorecard. This, even though you see a minus here, like Selenium does not support desktop application, this particular solution still had an edge with the Selenium because this application does not have a desktop client as such. But from overall tools capability point of view, this is what the scoring which happened, considering the critical business parameters or the features which are actually required as part of the continuous testing framework. And the next slide, we just see about the schematic representation of the test execution or the deployment cycle environments that we have for this particular hosted service. So it's there are around 5 environments, and it has to traverse through around 4 testing environments as such before promoting the code to production. So when there is a check-in happening, the continuous integration, the continuous testing process is triggered automatically from dev to QA. So, and there is a set of 3,500 cases which are auto-executed, and the success criteria of one suite automatically just invokes the next suite, and then it just goes on and publishes the end result as such. So while we see that there is no errors as such coming up in QA, then we further promote it to pre-production and editorial before pushing the code to production. And even in pre-production and editorial, we still make use of the configurations, and then we examine whether the configurations are existing properly by executing the which is the super set of cases, which is just the smoke suite alone. And the proven benefits that we saw out of this templated approach is parallel testing helped reduce the regression effort to a great extent. Nearly 1/10 of the effort was reduced. And then enhanced test coverage matrix, which was able to drill deep into the application, looking for each and every attribute which might not be humanly possible, and quality gate check at each and every stage of code promotion, and reduced regression issues once the code hit the production. Now we move on with the next case study, which is with respect to our product development. So this is again a kind of product which was developed by one team in a geography, and then the further customizations and the bespoke versions were either done directly by the end users who have procured the product, or it is done by the same product team who sits in a different geo by interacting with the country-specific users who are more specific to implement the country-specific implementation features and stuff. So again, here we had a kind of good distribution of teams working across geographies, and expecting at least a kind of 1,000 concurrent user base. And also, in addition to the critical functional testing aspects, leveraging or assessing the performance aspects again became another critical factor for this. So here is where the solution kit of Telerik testing framework, TFS for continuous integration, JMeter for performance testing, and SonarQube for static automation code review analysis helped us to a great extent. So TFS, as you know, this application technology is actually built on something called a mix of Telerik and RAC control framework, so that the product development follows a rapid channel. But from a testing point of view, the time or the effort actually involved from a kind of typical availability to the testing was very minimal. So here is where the continuous testing, which actually had to regress this application and then test across platforms of cross browsers involving multiple flavors like IE 10, Edge, Chrome, Firefox, everything were executed through a continuous testing parallel threaded execution. And also it had a capability to connect to their TFS cloud, and then during every code check-in, it was a kind of continuous test which happened. So smoke followed by regression, followed by performance. The evidences were just available to the UAT users, and for every release, the UAT was signed off by just looking into the automation results itself. Here you see a kind of overview of the solution stack, wherein TFS is the main cloud or the kind of repository which serve both as a platform for execution as well as the repository of the automated assets. So whenever the code check-in happened, the automation code which was distributed here, the build got deployed automatically, and then it triggered these scripts, which is a set of smoke and regression scripts and also the performance-based scripts across multiple proprietary VMs inside the premise itself. And then finally, after just going through this execution across 3 different environments, which is QA, staging, and production, provided QA is passed, then it gets promoted to staging, and then further to production, and then finally the complete set of tests are executed and the test results are out. This particular product, since it had multiple developers from geographies working on it, there were always regression issues coming up time and again. So continuous testing gave a big lever in terms of promoting the product quality. The regression issues were minimal, and also the defect leakage went on down to less than 1%. And 90% of manual effort, that is, whenever there is somebody doing a code check into the core product features, every time automated smoke testing was triggered, and then continuous testing enabled a faster feedback to the customers. So to summarize in a nutshell, the overall benefits goes like continuous testing is how different is continuous testing from our typical test automation is. Test automation is we build it and excise it only when there is a need. But continuous testing is something wherein we make it as a best practice. Whenever there is a code check-in, check-out, we just deploy it in the CI pipeline and then do a kind of reactive testing or kind of proactive testing even before it gets as a reactive testing to the next phase of the delivery. And early feedback, defect detection, prioritizing the business risk, and then aligning our deliverables appropriately, and increasing the effectiveness and efficiency of the delivery teams, and also taking a kind of risk-based approach testing when the critical modules are delivered first, and then comes the next set of business critical modules. How quickly can I jump and certify some modules so that it gets or hits the production quickly? So these are all the key benefits that we achieve out of this continuous testing. So having said all these factors, so invariably continuous testing is one of the key levers in the entire DevOps cycle, and it promotes a kind of good quality gatekeeper and then for anybody to go adopt a DevOps model and a continuous delivery pattern with proper quality gate checks as and when required.
And to add to what Jayanti said, we've been working on this templated approach for a while now. We've been building a framework in the backend that uses all these mathematical models and comes up with a template that applies to a specific input, and that input is basically what we get from our customers. It is still in a conceptual stage. It is still being worked on. We only have prototypes, but we're building tools and the model as such within Aspire. So needless to say, we are experimenting with this templated approach model, but it's been quite, to say correct to an extent, we've used it successfully for a few of our clients, but we'll continue to test it for a while before we will come out with it. Thanks. Thanks for attending the session. But before we close down, I think we have a couple of questions. So, Jayanti, apparently there's a question on the business point of view between the difference between continuous testing and test automation. Do you want to take it?
Yeah, Sridhar. So the main difference between continuous testing and test automation is we develop or automate a set of scripts and then keep it as an automated asset in the repository. We do not know when do we execute it and what priority it has to be given, what kind of business is actually driven, or to what extent it becomes a key qualifier in doing a business decisions for a particular customer. But as part of the continuous testing, it becomes one of the key levers embedded within the continuous delivery lifecycle as such, bringing out like the core business aspects of a particular product or an application or certified time to time whenever there is a deployment. And it becomes a best practice so that we do a kind of verification and validation in parallel. So developer puts something into the code base and the tester tests it and then approves it immediately. Without a manual intervention, if somebody is going to do it automatically, and the degree of precision and quality is going to be on the higher side. So it becomes a kind of seamless automated process which enables the time to market for any kind of customer. So this becomes a key difference between a continuous testing and a test automation.
Okay, thank you. So that's it from our question list. There is another question, but I think I've answered it. The question is about applying the approach to our customers, which we have for a few of our customers, but on an experimental basis. So I guess that answers the question. And that's all we have today. Thanks for listening in. Bye.